Okay, so this is for the physics project. Hello. And also hello. Okay, what we're going to do is we're gonna experiment with resonance using different length pipes and then an oscillator connected to a speaker, which is down there. Yeah. Up here we have a computer, which is kind of useless now. Then we have the sound system, and then we have the source of our oscillator, which is my phone. And we did a bunch of calculations in Excel to figure it out.
What is resonance? Resonance is the tendency of a system to oscillate at its maximum amplitude, associated with specific frequencies known as the system's resonant frequencies. At these frequencies, even small periodic driving forces can produce a large amplitude vibrations, because the system stores vibrational energy. So here are the two formulas we have from physics. The one on top is the basic formula used to find wavelength, which we in turn used to find the length of the pipe. And then the equation on the bottom is one we found online, which after our calculations we tried and found it to give remarkable similar, if not the same, results. Okay, now we're in Microsoft Excel. In the first column, the note desired is displayed. In the second, the semitone is listed. This is the distance from our keynote of A. In the third, the frequency of the note. In the fourth, the diameter of the pipe. And in the fifth, finally, our resulting pipe length.
Okay, here's all of our sorted pipes.
A flat to A is what, and then C and E.
Okay, and then it's a basic chromatic, it's 1 octave, 13 notes. And we are going to start off with these two, and we're going to go from there. After the tubes are cut to the lengths, this one being 64 inches, go ahead and hit it. We can see that it makes a sound. And so when we put it on there, we know what we need to set it to for the pipe to resonate correctly. Okay, for our first test, we're using the oscillator, and it's set to 164 hertz, and that is the key of
E at 164 hertz.
Okay, first test. Okay, we can see the pipe is resonating relatively loudly. You can see the volume over here isn't up very loud, it's actually pretty low. But we can turn it up, and you can actually see some pretty violent results. It actually starts to shake under its own energy.
This is high C at 265 hertz.
You can hear that this one's kind of quiet, but that's because we had to turn the volume down. And so we'll turn the volume up, and you can hear it. Okay, so we managed to screw up our speaker, and so now we give you handlebars on a broken speaker at the very end.
I can ride my bike with no handlebars, no handlebars, no handlebars. I can ride my bike with no handlebars, no handlebars, no handlebars. Look at me, hands in the air like it's good to be alive.
That doesn't sound very bad.
Raw crooked D. I can show you how to do-si-do. I can show you how to scratch a record. I can take apart the remote control, and I can almost put it back together. I can tie a knot in a cherry stem. I can